Okay, good morning, everyone. Just to get the logistics out of the way, could someone remotely type something in the chat if the audio is coming through? So I'm talking right now, just testing. Jason, someone says no, and someone else says no. Is there a separate button for sharing the audio? Okay, I think I'll just, okay. The meter says that.
Yeah, on the top left.
Top left.
There's going to be about a 30-second delay.
Oh, I see. Okay.
So Ellen said yes. Okay, they can.
Okay, very good. Okay, good morning, everyone. The people here in the room and the ones remotely. So this is an introduction to Unix and Linux and various varieties of Unix. I'm Victor Eickhout. I'm a research scientist at the Texas Advanced Computing Center, and in the room with me are three of my colleagues who will support this class both on the chat and live in the room. So we're going to be doing about 3 hours. I'm not exactly sure because I rewrote all the training material. This is the first time I'm doing this class. We're going to be doing 3 hours of pretty much continuously switching between a little bit of lecturing and then an exercise. And so you really need to do all the exercises to absorb the material. Listening to me recite a whole catalog of Unix commands is not really all that useful. So make sure you have some machine in front of you that's running. Let's see, on the Macintosh, you have the terminal program, or you can have X11. Linux machines go without saying. You have terminal manager, window manager or something, and you get an Xterm. On Windows, you can maybe use Cygwin. The machines here in the room have been booted off a CD, and so they're running a fairly authentic Unix. On Windows, another possibility is using VirtualBox. Yeah, that's the name of it, right? VirtualBox, and then you install a Linux distribution such as Fedora, which is the favorite of some of my colleagues. So, and no matter what you do, all this material will be more or less the same. And so it's also a good preparation for if you are later going to become a TAC user and you're going to use the big clusters. So I pulled up this on our web page. We have information about our 500,000 core cluster. Anyway, if you want to see what you can do with a lot of hardware once you graduate from this class, go to the TAC webpage. We at TAC offer other trainings. There is a very occasional intro to C, intro to Fortran. Those are the two main programming languages that you need to know in order to program our cluster. And we offer 3 or 4 times a year a 2-day training in parallel processing on Stampede. And so if you have been programming but only on a desktop machine, then you can take that training. You already have to have mastery of C or Fortran, and we'll tell you everything that is needed to become a parallel programmer on the cluster. And we have occasional other trainings, so take a look at our training page. I think there is a training mailing list that you can sign up for, and so then you get announcements. We do occasional things like defensive programming, cool stuff like that. Okay, so here on my screen I have my presentation and I have a terminal window. So you guys should do something like that. You should, so occasionally my terminal window will obscure part of the presentation, and so you can display my lecture in your browser. The PDF is available on the training page. And make sure you have a terminal window open. So no matter what system you have, you need to have some terminal window open so that you can actually type all the exercises. Okay, I'm going to start with some general blah about Unix, Linux. And so this is a supercomputing center, and so once you get into big computing, supercomputing, you'll find that the world is pretty much a Unix world. Macs don't really exist, Windows barely exists. So a couple of years ago, if you went down the top 500 list, you find that out of the 500, there are 2 Windows machines, 1 Mac, and for the rest, everything is Unix, Linux of some variety. So at least 97%. So knowing Unix, Linux is absolutely indispensable. Microsoft has a cluster product that we've occasionally played with, but we never seen any reason to deploy it. So learn Unix, Linux. Unix is one of the big computer programming success stories. I think it goes back to a DEC PDP-7. This is a picture of a PDP-11. Those were the popular machines that physics and engineering departments would buy and have somewhere in the basement. And so a couple of people started writing this operating system as an imitation of another operating system at the time, and the ideas that they came up with turned out to be successful enough to have survived for absolutely forever. Apple, after tinkering with different attempts at modernizing their operating system throughout the 90s, finally decided, okay, let's just take Unix and build something on top of that. And so even though you don't notice Unix when you're running your Mac, it is somewhere underneath because it's a very good basis to work on. Okay, the original Unix was a proprietary product, and you had to license it, and the source closed and all that. So a number of people tried writing open source versions and more accessible versions. For instance, there was Minix, which actually stayed popular for quite a while because I think it fit on 1 floppy disk, and so so it was very popular to just give it to your buddies and etc. etc. But Minix was kind of an academic project, and the author was had never the ambition of taking over the world. On the other hand, somewhere around 1990, Linus Torvalds, who lived at the time in Finland, where you basically have half a year of darkness, he had nothing better to do than write an operating system, and so and he published this in 1991, I believe. Yep. So Linus Torvalds, wrote something that he called Linux, which I think stands for Linux. Linux is not Unix, but that's only half of the story. The other person we need to credit is Richard Stallman, a very iconoclastic computer scientist at MIT. He's the father of open source, the GNU project. GNU also means GNU is not Unix. When you run Linux on your machine, you're really running Linus's lower layer called the kernel, and on top of that you run utilities and a shell that were written by Richard Stallman and his team at GNU. And so Stallman insists that we call it GNU Linux, which no one does, but it is actually accurate. So Linux is a clone, and Linux is really, strictly speaking, the kernel of the operating system. So the kernel of an operating system is the part deep down that manages processes and files, and you don't really notice that. As a user, when you open a terminal window, you talk to something called the shell, which is it's a program. It waits for you to type something, and then it uses the low-level functionality of the kernel to do something, and it reports back to you what the answer is. And so if we say this is a Linux course, it's really a course in using and programming the shell, which is a higher layer on top of the kernel. Now, there are different Unixes. There is System 5 and there's BSD. Those are the main flavors. And Linux, I think, looks more like System 5, and the Apple looks more like BSD. But those differences are really low. You'll hardly ever run into them. What you'll mostly run into is the fact that there are different shells. So originally there was SH and CSH, so that was the shell and the C shell. And with C shell, a long era of bad puns was born. That itself is already a pun, because SH was written by a man named Stephen Bourne, spelled, come on, I put it in a slide somewhere. Okay, can't find it. Bourne as in the action movies. So Stephen Bourne, and then someone decided to rewrite the Bourne shell, and that became Bash, which is the Born Again shell. And so someone rewrote the C shell, and it became the TC shell. I don't know what the T stands for. And there is the Z shell and the K shell. So the two main varieties are shell or Bash and C shell TCSH. In fact, if you're on a Linux machine, SH and CSH are licensed products, and so on a Linux machine, those two are just synonyms for Bash and TCSH. Anyway, so there is Bash and there's TCSH, and for a variety of reasons, TCSH tries to be more friendly, but I think ultimately it's flawed, and so we advocate that people only learn the Bash shell and use that as their product, as their preferred shell. So if you get an account attack, it will have the Bash shell as default. And in fact, you need to put in a request to us if you want to have that changed. Bash shell is, to me, just better than the C shell. And so that's the only shell I'm going to be teaching. A whole lot of things here are actually going to be the same for the two shells. But once we get to the final part of this training and we're going to be doing shell scripting, everything is different between the two shells. And shell scripting is just much harder, sometimes impossible in C shell. And so that's why we're using Bash. Okay, so there are different types of Unix, there are different shells, and then there is the concept of a Linux distribution. And I'm entirely not going into that. The differences between distributions are really deep down, and you'll hardly ever run into that. Not before you're considerably more expert than you'll come out of this class. Okay, why do we use Linux? It's simple. It's very good for not getting in your way when you try to get a lot of performance. So supercomputers like it. Of course, it's free, so that's also a reason that we use it. Functionality. This is, of course, a self-perpetuating phenomenon. Scientists use Unix, so they write software on it. So the next machine that they buy will be a Unix machine, and so this partly is historic, but partly there are also very good reasons why Unix and Linux are the best system to use. Flexibility and portability. If you've developed your software on one sort of Unix and you try to install it on a Mac, or you try to install it on our supercomputer, chances are that with minimal tinkering you can actually get that software to run. So the portability between fairly different architectures, between fairly different machines, can be high. Okay, there's 40 years of development behind it. Yet people still occasionally miss some things, like I don't know if you caught that a couple of weeks ago. What was the name of the vulnerability, guys? That bash vulnerability. It had a cutesy name. Shell shock. Thank you. Yeah, so this software has been around for a long time, and still people occasionally find errors in it. It happens. In academia, it's the standard. It's open source, and so you can just you can download a Linux distribution, but it comes with many machines. It's pretty stable, lightweight, and it's easy to develop for. Okay, I've sort of said this. So there is a kernel, which is software deep down that manages your activities and your files, your data. And then there's the shell that you talk to. The shell is the user interface. Okay, in Linux, Unix, everything is either a file or a process. It's a beautiful design. If you get into the system, a terminal is a file. A disk drive is a file. Just about everything is a file unless it runs and it's a process. So a file is a collection, in the abstract, it's a collection of data. And so a lot of what we'll be doing is just file operations. How do you create a file? How do you move it somewhere? How do you organize files, etc., etc. The shell is constantly in this loop. It reads a command from you, it processes it, it executes that. These colors are not optimal. It displays the result and it displays the prompt again. So, so here's a terminal window, and I type a command, and after almost no delay, there's the answer. So who am I? And it tells me what the name of the user is that I am. So is that the first exercise in the class? We'll get to that. So just for the heck of it, type "who am I" in your terminal window. See what comes back. Okay, no spaces between who and M. No capital letter on the I. Okay, the people that have been running on the lab machines, what do you get? Marielle?
No,
correct. Yeah, so you're kind of, that's because you booted from a CD and we don't have, that's the only user probably installed on that system. Guys in the back, what is it telling you? Hey, perfect. Okay, so Jeff. So there is another command, finger, that means dig up information on Jeff. And okay, see, my machine has no Jeff. What happens if you type finger Jeff?
Says I'm on PC.
Yeah. Let's see. Okay, so if I finger tac, it tells me that there is a user admin who's the tac administrator, and there is a user tac staff. And okay, this window is not wide enough. It scrolls around a little. Anyway, so you see that Unix is a multi-user system, and so there are all sorts of users on your system. You can just experiment, seeing what turns up something. If you do finger admin, I have no idea if anything happens with the lab machines. Anyway, so user tax staff has been idle for 13 days. Anyway, so so this is the you type a command, the system executes it, gives you something back, and then it sits there waiting for your next command. So Linux interaction. Okay, I'm doing the barest thing here. I'm typing in a terminal window. You can have more graphical ways of interacting. So especially on my Mac, I use something called X11, and that's also what Linux machines use. So you can have something that is slightly prettier than this. In fact, the lab machines have a fairly nice interface. It has all sorts of cute special effects. Okay, open the terminal. I hope everyone has that by now. So this is a terminal window, and I hope that regardless what machine you're following this on, to access a Linux system, you need to have an account. So Unix is a multi-user operating system, and so even if it's your personal machine and no one else will ever use it, you still need to create an account for yourself. And in fact, Mac and Windows machines now have the concept of an administrator and a regular user, and the administrator can do more with your machine than the regular user can. So that is the Unix influence that you're feeling in operating systems that otherwise don't look all that Unixy. Okay, exercise number 1. We have already done most of that. Who am I and finger. And another command is who. So this says that there are apparently that let me show you something fun. SSH stampede tacu Texas edu. Oops. Okay, I'm on Stampede. If I type who, these are all the users that are logged in on Stampede. So if you type who on your machine, it will probably tell you that you are logged in once or twice in different guises. But on a bigger system, you get this sort of stuff. Okay, and just a preview of coming attractions. There are 125 people on Stampede. I will explain to you what that means later. Yes. Oh yeah. Let me keep that window around just in case I want to do something else with Stampede. Okay, that was exercise number 1. Okay, so that was a bit about users. We're not going to do much with users. The most of the activity that we're going to be doing is about files and a little bit about processes later. So a file is a basic unit of storage, typically on your disk. A file has a name, and Unix file names can be quite adventurous. Contain any character except for a slash. So if you want to have spaces in file names, that is absolutely no problem. If you want to have a new line in your file name, that is also no problem, but you're going to run into certain problems using that file. Anyway, Unix file names can be pretty much anything. Let's just start with alpha, probably. Your file names can be pretty long, so if you want to give your file a long and descriptive name, that is allowed. And there are some file names that are special. If they start with a period, then they are called hidden files. Okay, exercise number 2. So the very common Unix command is ls. ls is short for list. Do that on your machine and see what comes up. I don't even know what happens with these machines. There. Okay. So on the lab machines, there is only something called desktop, which is here on my Mac too. So these are all the files that you have, and they come in a variety of things, a variety of varieties. ls-a, okay, that -a is an option. Shell commands can often have options, and options usually are a single dash followed by a single letter, or a double dash followed by a word. So ls-a means list all files. Well, didn't ls give me all the files? Okay, so here you see a couple of dot files. So okay, those are called hidden files, or colloquially dot files. And those are typically things that you that get automatically generated by someone, by some process, or that you simply don't want to see. They're often configuration files. So these are all the files that you have, but usually anything that you get from ls is the only ones that you're interested in. Okay, the next command, touch. Touch is a very useful command for doing demos, but otherwise its uses are limited. If you type touch followed by something that is not the name of an existing file, then it creates an empty file by that name. So that's why I like it for demos. Touch, this is a new file name. And okay, so I typed that and I didn't get any response. What does that mean? That it didn't work? No, rather it means it did work. Unix is a very silent operating system. If something worked, then it simply doesn't report anything back if there is no obvious output. So this worked, and so if you want to see that it actually worked, then you do ls, and you see that there is now a file by that name. Okay, in your terminal window, there's no menu bar, so you cannot click around and find out what can I do with this file. And so on Unix, you kind of need to know what you can do. But there is a help facility which is delightfully 1970s. Man means manual. So if you ask for the manual of ls, go ahead and type that and then hit return. Then it says the name ls is list directory contents. And you're now, yeah, let's hide that because it's, no, yeah. Jason, did I hope I'm still there?
As long as you don't hit stop broadcast, we're okay.
Okay, I hit the hide button. I wanted to get that. Are we still good?
Yeah, we're fine.
Okay. Okay, so you see the colon at the bottom of the screen. You're in this is technically called the pager. So you're in a mode, and if you hit the space bar, then it shows you the next screen, and there's a whole bunch of commands. U is up, and I'm not going to teach you this. I'm just showing you that there is this help facility, and you space through it with the space bar, and if you've had enough of it, you hit the Q, and you're out of it. Okay, so that thing, that reader that you got by typing man, that will appear in a number of other contexts too. And so the most important thing to remember is Q, which gets you out of it. Okay, what does it say on the on the exercise? All right, I'm going to fill up my coffee while you guys do the exercise. How do you find out the size of a file and the last time it was touched? Well, let's start with that size of a file. So with everything that you've learned so far, try to find out how you find the size of a file. How are you going to do that? Hint, man. Maybe I should have taken an option that was a bit earlier in the alphabet. Did everyone scroll down to the S option? So there is an option.
Did it by itself? Like it's handed directly to me. When I type, it's something.
What did you type? Right. Yeah, so this reader, the official way of doing things. Okay, so if you type slash followed by any term and then you hit return, You can use the arrow keys. No, this is not what I want. Size. Anyway, so you can search through your man page, and at some point you'll find the -s option. So if you do ls-s, you'll find a whole bunch of size zeros, and of course this file that I just created is an empty file, and the only file here that has any size is evil.sh. So why do all these files have size 0? Well, that is because they're not actually files, or they are files, but they're special files, they're directories. Okay, each file can hold raw data. Unix files can be pretty much arbitrary. Any sort of bytes can go into it. And how that is interpreted depends entirely on the application that uses it. So you can have text files with readable text. You can have numerical data that comes from a program or is input to a program. And in scientific computing, we often use binary files. So numbers are not stored as sequences of characters, but as their binary representation. Yeah, quite irregular. Okay, so we just created a file that was empty. This is a new file name. So let's create a file that actually has something in it. So the next command is cat, which is short for concatenate, which is kind of a strange name. So let's ignore that. And cat, and this arrow means the output goes to. So cat is a command that, if you use it this way, it takes the terminal input, and with the arrow is called output redirection. I tell it, put the output in a file with this name. See, the shell now knows that this command is not finished, so I'm not getting a prompt, and it's waiting for me to give some input, which it will then, doesn't really matter, input some text, doesn't matter what. Okay, so when does it stop accepting my input? Okay, you see on the slide that there is a hat followed by a D. That means you have to hit the control key and keep that down, and then you hit the D key. Okay, on some systems it gets, on some it doesn't. So hat D means hit the control and hold that while you tap the D key. And that is always the sign for this is the end of the input. And so cat then knows that you're done inputting stuff. You probably need to put that at the start of a line. And so now you have this file. And so here's the second use of cat. If you do cat with a file name, then it will concatenate this file name. So cat, strictly speaking, means take input and output it somewhere. And so if you type cat arrow file, it means take the terminal and put the output in a file. if you write cat file, it means take the input from that file and put it on your terminal. So see, whatever I just typed is now in this file. And so if I cat it, it shows me on my screen. Okay. So now I can ask, how big is this file? And it turned out to be 8 blocks, which is the minimum size of any file. Let's see. You can cat it. So on the previous slide, I said files come in all sorts, and so there is a quick way of asking what sort of file is this. So I type file, text file, and it says text file is ASCII text. So what is one of those zero-size things was a directory. If you do this on the lab machines and you do file desktop, it will probably tell you that it's a directory. Okay, so you can do cat on a file, you can do file. WC means word count. Okay, this is not mentioned in the slides. I should really put it somewhere. After a while, you get sick and tired of typing the same thing over and over again. And so there's all sorts of things you can do to make life slightly easier for you. For instance, if you use the up arrow, you get your previous commands. So, for instance, you do the up arrow, you get until you get this file. Then I use my arrow back. I erase this, and I type something else. So you can use your arrow keys to get previous commands, and then use the arrow and the backspace or delete key to edit your commands. And so that's how I did this. But yeah, let's keep it at this for now. So WC means word count, but it actually counts more than words. Says that the file has 2 lines, 7 words, and 43 characters. So if you're only interested in how many lines there are in the file, oh, by the way, I just did up space and now backspace. Up arrow, back arrow. If you want to know how many lines there are in the file, then you do word count minus L. Okay, so this is just some elementary file manipulation. Every file must have a name. Okay, we're going to the next concept of a directory. So if you have multiple files, if you want to have the same file name but associated with different projects, then you can put projects in directories. I assume the concept of a directory or a folder is not that strange to people. A directory is a special kind of file, namely it groups together other files. So think of a directory as a container that holds other files. On Mac and Windows, it's sometimes referred to as a folder. So folder, directory. Okay, this exercise, everyone do this, even if you were just reading along with my previous one. This is important because all the next exercises are going to happen here. So what can you do with a directory? Well, first of all, you have to make one. So type make dir new directory. Again, if you don't do anything wrong, Unix will simply not give you any response. So the command succeeded. If you do ls, you'll see that the new directory is there. Okay, here's the next option on on ls. Do ls minus L. ls minus L is the long form. So that will give you a whole lot of information on your files. Has everyone done that? You get all sorts of gibberish. Good morning. Okay, so yeah, so the obvious stuff here is, of course, the final column, which is the file name. And then before that, if you look at new directory, it says October 9, 948. So that was when the file was created, probably. Technically not entirely true. 68. I actually don't know that. Before that, text staff and staff. So that just says that the file belongs to that user. And then before that is all sorts of gibberish. So the point to note about the first bunch of characters is that look at the last 3 lines here. The last 2 say -rw, and then the line corresponding to a new directory. So this was a text file, and this is a text file, and this is a directory. You see that there is a D here, where there is a dash here. So an easy way of finding out what are the text files and what are the directories is do ls minus L and watch for that D. Okay? So I've created the directory, and what happens if I ls new directory, the directory? It gives me no output, which means, anyone want to hazard a guess? Thank you, yes. Directory is empty, I just created it. I know. That's on, yeah. That's also on the next slide somewhere. What would happen if you would try to cat this directory? Okay, I'm too much tempted to type this myself, so let's introduce this. Exclamation $. Is a very convenient shortcut. It means take the last word of the previous command. So I've done something with a file, and now I want to do something else with the same file. So I type cat of whatever was last on the previous line, and I get an error message. You cannot cat the contents of a directory file. So directories have a content in a slightly different sense than the file has a content. With a file, you say cat the file and you get the contents. With a directory, you have to ls it. Let's do that on something that actually contains something. So documents is a directory, and I ls it, and it tells me there is a bunch of stuff in that directory. Okay. There is the concept of a working directory. So you can create a whole bunch of directories on your system, and you get kind of a tree. It starts at the root of the tree. This is an Australian tree, it grows the other way. So the root of the tree is called /, and then there are subdirectories, and typically there is a directory called users or something, or user, and then there's a list of the users, and then every user has their own directories, and so that's how a whole file system is composed of directories and files. And if you're logged into a Unix system, there's always one directory that is the working directory, or current directory, or current working directory. So that is where you are in some sense. Okay. That's actually this exercise. What am I doing here? Okay, let's get this out of the way. Okay, so I made 2 text files and I made a directory. Now, how did I make that directory again? What was the command? mkdir. L? No, I don't even know what that does. mkdir. I don't see an L option. Okay. mkdir, and then I had a directory name. Oh, you mean name? Okay. So that's how I created the directory, and I made a text file by doing cat into it. Or I can do touch and create an empty file. So if you ls it, you just get those names, and it doesn't immediately tell you what is a directory or not. You've already seen this one. ls-l gives you all the information, including in the first column. But there are a couple of shorter ways of doing it. My favorite one is -F. So type that. So the text files are just displayed the way they are. Not a directory with a text file. This is a text file. This is a text file. And I made a new directory. And you see that it puts a slash behind it. So that means that it's a directory. And all these other things are also directories. And if you do this, then there is a final thing. Files that can be considered as commands, and we'll get to what that means precisely, are indicated with a star. So text files, directory, executable stuff. Okay, go ahead and type ls star. Oh, I haven't explained what a star is. Star informally means everything. So type ls star. You get something that is slightly different from just typing ls. If you type ls, it will give you all the contents of your current directory. If you do ls star, how would you describe what it gives you? Has everyone done that? This file. Well, so if you do ls star, it will look at your files and just give you the name, but it will look at your directories at this level and give you the contents. So if you look at what I get here, so apparently I have no movies, and in the music is something called iTunes. So ls star gives you sometimes too much information. So this is a way of shortcutting that. ls minus d means don't go into directories. Okay, so I'm just showing you a bunch of options, different ways of visualizing stuff. Sometimes you want the effect of ls star and show what's in subdirectories. Sometimes you don't. Okay. So you have your directory tree. You have your directory tree, and you're always in exactly one working directory. So pwd present working directory tells me I'm here. Well, and that means that if I create a new file, it will be made in this directory. Now, oops. So I had something called new directory, which you guys also are supposed to have. And so I can do change directory, new directory. Okay, so if you cd to a new directory, then that directory becomes your working directory. And now if you create a file, then it will be created in that directory. So this is very useful. So you create a directory for every project that you have, and the output of what you're working on that project will stick to that directory. So it's a way of sorting your work. cd new directory, and now if you do pwd, it says I'm in users tag staff new directory. Did everyone create that? Okay, type the next command. Make their inner directory. So I've made a new directory, but I'm still where I am in the new directory. So I can do cd. Okay, next shortcut. If you find yourself typing a file name, I am now hitting the tab key. So type cd space in, and then hit the tab key. Did that work for everyone? Did it auto-complete that file name? So on most shells these days, if you type a partial file name, sometimes even command name, and then you hit tab, it will auto-complete it. Okay, so I cd into my inner directory, and I do pwd. And this directory is empty, so there's nothing ls. In fact, there are two mysterious files, dot and dot dot. Dot is the current directory. Dot dot is kind of interesting. Dot dot is one step back up the tree. So so it's easy to cd into a directory. To change directory into a directory, you type cd directory name. But what if you want to get back? So the easiest way of doing that is cd dot dot, and now I'm in new directory, which contained the inner directory. Okay, cd dot dot means one step back in the tree. And for something completely pointless, cd dot means change directory to the current directory. So that doesn't do anything, but you can confirm that that actually works. And so there was an inner directory, and if I cd into that, so from the root of the tree, there is the directory with all the users, then there is tax staff, which is my directory, and then it had a new directory in it, and an inner directory in it, and that's where I am. Suppose I want to get back to my home directory. Then there are two ways of doing that. So I can say go to the previous directory and go again to the previous directory. Okay, the hash sign is a comment, so that gets ignored by the system. And so that's where I am. Okay, cd new directory, inner directory. The easy way to get back to your home directory is just to type cd, and you're back home. Okay, I'll give everyone a minute to do that all for yourself. So notice a couple things. You can cd into a single directory, or if you know the path through your directories, you can say cd this directory and then in that directory. So you can make whole paths to go in one step somewhere in your directory tree.
So that line where it says twice up,
Yes.
the three, is it all together, the line below? Like twice up the three, or is that just?
Oh,
just,
yes.
Okay.
This is wrapped around.
Okay.
Yeah. I'm trying to keep the font readable. Should have made a shorter prompt. What is the prompt again? I'm no virtuoso in that. No? How does that go again? Oh, right. Too short. I want to get nostalgic for VM370. Okay, let's do something slightly less nonsensical. Interesting. It got expanded. I didn't mean that. Yeah. Okay. Okay, that's enough toying around. I didn't break anything. Okay. Something about so here I showed that you can put a couple of directories together, and I said that slash is the root of the tree. So there are two types of it's called a path. There are two types of path. This is a relative path. So starting at the current directory, go into new directory and then in a directory. But you can also have an absolute path. So I could say cd / users tax staff new directory, and let me lift that slightly. So this is called an absolute path because it starts at the root of the file system. So relative versus absolute path. Anything that starts with a slash is an absolute path. Anything else is relative. And you can do really silly stuff with that. So let's see, users tag staff, go up one, and then again tag staff, and then current directory, and then new directory, and then down again in the new directory. So you can start at the root, go into users tag staff, oops, go back to users, go into tag staff, stay in that directory, go into the new directory, go back to tag staff, into the new directory. So you can string together paths like that. And this looks kind of silly, but in practice, this happens quite often because you get part of the path from one source, part of the path from another source, and you just slam them together. Okay, paths. Has everyone, we've sort of done this, right? So type cd, confirm that you're in your home directory, and then go into the new directory and type cd ... You'll see that you're back home. I think everyone will trust me on this. So there's actually 3 ways of getting to your home directory. You can, 4. You can do cd without any arguments. That puts you in your home directory. Tilde, if you use it by itself, it means your home directory. If you write tilde eickhout, it means the home directory of user eickhout, which is me. And then there's $home. So there's different ways of getting to your home directory. We've seen these commands. cd is change directory into a directory, so you go up and down the tree, or if you have an absolute path, you go to a specific location. ls -a is hidden files. Couple new ones. mv is move, and move is really rename, or the 2 are synonyms of each other, moving and renaming. cp is copying files. rm is removing files. Let's not do rename. So let me give everyone a minute to do exercise number 8. So you go into your new directory. You create a test file, and then cp is copy, and then confirm that it's actually there. Remember that the #d means Control D.
There's a new one. I lost it.
So,
So I need to add it again. So that's it, right?
how far is everyone? So we've created um, uh, so I'm just annotating what I'm doing. Should have done that right off from the start. So these comments you can completely ignore. This is just for me to tell you what I'm doing here. So CD tilde means home directory / new directory. You could also have done this. And now has everyone created that test1 file? So there was a directory that we created in the previous exercise. Now there is a test1 text file. And in fact, if you do this, then it will tell you that inner directory is indeed a directory. Copy test1, test2. Everyone done that? So now I have two files. And in fact, if I cat the second one, then it has the same text in it that the other one has. And they're really copies of each other. They're the same, right? Okay. This is not on the slide. So the mv command move has a couple of different forms. So if you say move test2 to test3, then it renames it. So see, what used to be test2 is now test3. And if you do this, move test1, test3 in a directory, this means if you do move and the last argument is a directory, then it means take everything that comes before it and put it in that directory. So you do this, and you see that your files are no longer in this directory. But if you look in the other directory, and that's where your files are. Okay, so many Unix commands have a couple of different forms. So move is a rename if it's between two files of the same type. But if you do move and the last argument on the line is a directory, then it's actually then it moves all that stuff into the directory. You had a question?
Yeah, does it really matter in this directory you are prior to issuing the step?
Well, if I'm in a different directory, then these files don't exist. So, but yeah, you can. You can read test3 and put that current directory test2. So I can take any sort of path to see, now this file is here and it's not there.
The answer is yes. And it's a caveat in the sense that if you're using relative paths, then the answer is
Yes, right. So, okay, good point. Yes, if you use absolute paths, so I can do move users tag staff new directory test2 to users tag staff new directory inner directory. Right. If you use absolute paths, then you can do it from any location. But if you use relative paths, then it's relative to your current location, and so the file needs to exist. Okay. Right. Copy. Copy new directory to very new directory. So the copy command does not work between directories. Oops. So in order to copy directories, you need the -R option, which stands for recursive, because a directory is a part of your tree, and so you need to tell it that it needs to recursively copy that part of the tree. Okay, that's what the exercise says. Okay, I shouldn't have given it away. It was an exercise. So everyone try this for yourself. Go into new directory and try copy in a directory, see that you get an error. By the way, we're about an hour and 20 minutes into this, so let's take a 10-minute break, give everyone a chance to breathe. Okay. Okay, I pushed the button. Yes, so in about 30 seconds I should be remotely audible. Here's just a couple of commands. Quota doesn't seem to exist on every system. No disk quota. If you use our clusters, you'll find that there is definitely quotas, although the quota command doesn't give you all the information. du is useful. It tells you where all your space is going, and so if you try to find out why am I running out of disk space, interesting. Huh. Okay, and du minus s only gives you the total. So if this is in, this is probably measured in kilobytes, so 4 gigabytes. So no, I don't know. Maybe it's in bytes. Need to read the manual. Quota and du. Okay, let's do. So I showed you that. No, ls minus l. If you do ls minus l, you get a whole bunch of gibberish at the start of every line. So the first character is a D if you have a directory. And after that, you get 9 characters that can, RWX, RX, R. Okay, what that is permissions. So, so you may want to hide files from other people, or you may want to make files visible to other people, and so there are permissions. There is a permission to read a file, there's a permission to write a file, and there is a permission to execute a file. So take a look at that, and you'll see that there are a couple of directories that have execute permission. What does it mean to execute a directory? Okay, it means that you're allowed to enter that directory. So to execute means 2 different things. Read, write, execute. Okay, so those are the first 3 characters. And then there is again RX, RX. What is that about? Well, you can give permissions to 3 different groups of users. First is yourself. So, and then there is the group. Okay, I'm not going into groups, but you can declare people to be in a group with you. So if you're, this is mostly all this, the 3 levels are mostly relevant if you're on a machine with other people. So if you're on our clusters and you're working on a project for an advisor and there are other students, then, or if you're a professor yourself, if you create a project, it also creates a group. And if you add people to that project in our user portal, they wind up in the same Unix group. And so it becomes possible to have files visible to the people that you're working with, but not to the outside world. So there's yourself, there's your group, and there is the rest of the world. And for all 3 of these, you can have read, write, and execute permission. So, so write permission also includes the permission to delete a file. And so what you often will see is that this is a popular one. So you create a file and you are allowed to read and write it, but other people are only allowed to read it. So read, write, not execute, and so this is you, and the group, the second three is read, not allowed to write, not allowed to execute, and the world is also allowed to read a file. Okay, let's do this exercise. So start typing. Create a file. You can cat it, and if you do ls-l on that file, it will tell you what the permissions are. Okay, has everyone got to this line where you so you create a text file, you can cat it, you can ls it, and then there is chmod. I always pronounce it chmod, but change change what? Modality? Change permissions. Yeah. Okay, so what does that line mean? Oops, hitting the wrong button. Mode bits. All right, mode. Okay, I have this file. Change the file mode, and how do I change it? Well, I affect the, so let's first ls-l text file. So you see that I'm allowed to read and write it, and other people are allowed to read it. And now I change the mode so that the user loses the read ability on text file. So you see that the permission has changed. I no longer, the first three positions, okay, the first position is the directory or not, and then you get read, write, execute for yourself. And so I don't have read access. So if I try to cat this file, it says permission denied. I don't have permission. So you can change permissions that affect yourself. Okay, now I think change permission. Oh, let's give the world permission to write that file. It's pretty silly to do, but just to show that it's possible. So you can use these mnemonics where you say user take away or world grant permission. But the way we often do it is numerically. So read, write, execute from right to left is 1, 2, 4, or left to right is 4, 2, 1. And so if you set permission 6, 4, 4, 6 is 4 plus 2, so that's read and write. It would have been 7 if it's read, write, execute. 4 means the group is only read, not write, not execute. So 644 is kind of a popular permission. It means that you can change the file, everyone else can see it. So what do you think 640 would be. What would 640 be? How would you describe that? So the first number is your own permission. Second number is group permission. Third number is world permission. Okay, guess. World permission 0. Means the world is not allowed to read the file and not allowed to write the file. And it's not a program, so execute. Okay. So we've been using the arrow. It's called output redirection. So the cat command means take input from somewhere and put it somewhere else, and the arrow means put it into a file. There are various variants on this. So for instance, I think I'll go quickly over this. So a single arrow means put the output in a file. A double greater than means append the output to a file. So I want to get to the I want to get to the fun part of Unix. So somewhere we had a text file, right? Where are we? No, wait a second. It says use exercise 11. No, not 11. There are 2 exercise 11s. How fun. Okay, make sure you make a text file that has those 3 lines in them. So let me do that for a second. Cat into text file, 1 line, and another, and more. Control D, I think that's I think that's what I'm using. Okay, so make sure that in this exercise, I'm introducing 1 command, namely grep. Global regular expression P. I don't know. The names of Unix commands are all a bit cryptic, and grep is search for text in a file. So you have this text file, cat text file, and the grep command is search for so this answers back to you the lines that have this. Now, quite often, just searching for something is not all that you want to do. You may, for instance, want to know how many lines are there that have this text. Okay, so what you learn in exercise 12 is the vertical bar Some people will have that, most people will have that somewhere in the upper right of their keyboard. Does anyone have a keyboard where it's somewhere in the upper left? It's one of these keys that is not entirely standardized. So the vertical bar is shift \. I have it on the key above the return key. So grep A in text file. WC was word count, and WC minus L is word count and only report the number of lines. So the vertical bar is pronounced pipe. You make a pipe between two commands, meaning one command produces output and it gets pushed through the pipe into the next command. So what's happening here is I search for A in the text file, and instead of displaying the output to the terminal, this pipe then takes the output and feeds it immediately into this next command. Has everyone done that? What's the output that you get? Yes, I get 1. Who said 2?
I have a few more things in the back.
Yeah, a few more. Okay. Yeah. So whatever this output was, this gives the correct count of it. Yeah. If you have more things in the file. So, and you can do all sorts of things with this. So here's a Unix command that is occasionally useful. TR means transpose, and you give it a couple of characters and you can change them into other characters. So this is an easy way of uppercasing text. I'm sure that there is a different command for uppercasing, but you can do most things in Unix in at least 2 different ways. So I search for a text in a file, and whatever the output is, I pipe that into translate lowercase into uppercase. You see that you get that result. Nope. 2 different files. So so you see that in this file there are lowercase a's and uppercase a's, and it only gave me the line that had the lowercase a because that was what I was searching for. So a very popular way this is often a very useful option for grep. -I is ignore the difference between uppercase, lowercase. And so if you then take this and you no, you should get more lines. Okay, that was in fact an exercise. Okay, yes, as I feared, we're not going to finish all the material in 3 hours. Okay, I'm going to go easy over this stuff. regular expressions. So I was just searching for literally an A in this file. Let's do this exercise. So with regular expressions, you can define a search pattern to search through a file. So let's just type these things, and on the right it says what it's supposed to mean. So confirm that if you have that text file that you are supposed to be having, confirm that you get results that do this. So on the first line, you search literally for an E. On the second line, dot means any character. So you're searching for an E followed by any character. Well, what was in your text file? See, there are two lines that end with an E, and there is one line that has an E somewhere in the middle. So if you grep for an E, it finds all three lines because they all have an E in it. But if you search for an E followed by a character, then it is not finding the last line, because in the last line, the E was at the end of the line, so it didn't match the search pattern. Okay. So what would this do? Star means any characters. And that didn't do it because I probably needed to put quotes around it. So some search patterns you can just type as they are, but usually you need to put quotes around them. I thought
This seems so. This seems to produce the same result with the first one.
This one? Not in my text file. I'd have to look at your input. Oh, and maybe it worked on my Mac. Okay. What is probably going on here is that the interpretation of search patterns is not entirely uniform over shells. So some shells try to be clever, and they see that you're doing a grep command, and so they put their own, in effect, quotes around the search pattern. So it kind of depends. I probably tried this out. No, this is a Mac, and I tried it on my Mac. Anyway, search patterns are not entirely standardized. Putting quotes around it is usually a good idea. Okay, search regular expressions, search patterns is a topic for a whole lecture. So you can say search for this or that. The question mark is maybe this character or maybe not. There are all sorts of ways of doing it. So let's. Yes.
Can we then assume that such patterns should be protected?
If you put double quotes around them, they're probably standardized enough. But there are occasional small differences. Once you start doing escapes, then it's not. Then it can be slightly machine dependent. Unfortunately, yes. So as an illustration of search patterns being not entirely standard regular expressions, why don't we all do exercise number 16? So this illustrates the use of regular expressions on the shell level and for grep. So the two interpret the star slightly differently. So please do this exercise. Create a directory and create a couple files in it. So the star is usually pronounced as any character or any string, any characters, plural. Everyone getting this so far? So on the shell level, ski star is interpreted as find files that have S, K, I, and then followed by any number of characters. Now, if you do ls, that means give me all the file names. The vertical bar is the pipe character, so it takes the output of one command and it feeds it to another command. So you list all the files, and in that output you do grep, which is a string search, and you search for ski star. Grep interprets SKI star as an S, and then a K, and then any number of I's. So on the shell level, star means any number of characters. In grep, star means any number of what I've just said. So this is confusing. Regular expressions are so useful, and unfortunately they're not entirely standardized. So for grep, they mean something slightly differently from on the shell level. And I would say that this is the aberration. Other programs that use regular expressions will use it the same way as that grep does. So SKI star means an S and then a K, and then 0 or more i's. So the fact that it matches SK illustrates that this is S followed by K followed by 0 i's. Okay? So grep is a first example of a Unix tool that is useful to compose with other commands and do something complicated with it. I'm just mentioning awk and sed. If you go to the O'Reilly webpage, you can find a book. It's called Sed and Awk, and it's about 400 pages. So you can do a lot with these tools. And so I'm not even going to start. Sed means stream editor, and awk means Aho something, Kernighan, name of the authors. Let's not do this. So there are Unix tools, sed and awk, that can do really interesting stuff. My favorite application of awk is I want to search for a string in a file, and then I want to display the line before that. So that's my favorite thing to do in awk. You can also do it in sed, but you know the saying about a hammer and a nail, and I learned awk before I learned sed, so I do everything with awk. Anyway, it's time we do something about Unix shell scripting, and so I first want to tell you what precisely is a command in Unix. Okay, so you've used the ls command a couple times. Ls is list the contents of the current directory, or in fact you can ls on a single file. So what precisely is ls? Okay, one way of finding out what ls is typing which ls. And so if you type ls, it actually activates. A command is not just a command. A command usually is a file. Namely, it's the file bin ls. So apparently, the command ls is a file. So now let's take a look at that thing. So if I give a long listing of it, it says that it was created on October 25, 2014. It's owned by a user called root, and root is allowed to read, write, and execute that. And you, as the ordinary user, are allowed to read the bin ls file, but you're also allowed to execute it. So apparently, it's executable, and with respect to root, you are an other user, so you're allowed to execute it. Okay, so that is ls. So I can also do file, which tells me what kind of a file is this, and blah blah blah. 64-bit executable means it's something that was compiled. So you'd better not cat it. Yep. Okay. Okay, so there's bin ls. So if you type ls, it's actually a file that is somewhere deep in a system directory. Does that mean that you can execute anything that is in any system directory? No. Type echo path and see what that turns up for you. So $path that's called an environment. Anything that starts with a dollar is called an environment variable or system variable sometimes. And a $path has a value. This $path is called the search path, and so it's a list of directories where if you type a command, then the shell will look in these directories, and if it finds your command in one of them, it will execute it. So what was ls again? It's bin ls, and you see that /bin is in your search path. And so this file bin ls gets found, and it has executable permission, so it can be run as a program, and it's in your path, and so it can be executed. Okay, so the important points are that if you want to make something executable on Unix, it needs to have X permission, otherwise it's not executable, and it needs to be in your search path. I think this is where we yeah. Okay. So the remaining 45 minutes of this class are going to be about shell scripting. Shell scripting is a way of writing your own Unix commands. So you can write something, if you don't like the system ls, you can write something that is called list, and that does a listing that is more to your liking. So we're going to write a couple of Unix shell scripts, and they behave just like regular Unix commands, except that you've written them. And this is great if you you start doing complicated stuff on a Unix system. You have your own bookkeeping and data processing, etc. And so you can cobble together Unix commands, put them in a script, and have them act like your own Unix command. Okay, so in order to write your own shell script, you need to do three things. The first line, you need to tell it that it's a shell script. So you need to tell it what command interpreter to use. You need to set executable permission, and you need to make sure that the system finds it. Okay. So maybe we can do this one together. Type along with me. So cat So we're going to make a shell script. So cat into something. And this first line, you just have to put this into your motor memory. every shell script you're going to write starts with that line. And then you put in your script an actual Unix command. And hit Control D. Okay, so I've made this. Now, how do you execute this? So I've told it that it's a shell script, that first line bin bash, but it needs to be executable and it needs to be on your path. So if I type work.command, and it says command not found. What do you mean command not found? So there are two conditions. So let's start with this one. Okay, wait a minute. It didn't find it. So let's tell it where it is. Work.command, that's the one that you need to execute. So it couldn't find it. It wasn't on the path. So I'm telling it, okay, here it is, execute. And now it says permission denied. So so that means I don't have permission to execute this. I start my line with this, and so it must be a command, but it doesn't have executable permission. So we use the chmod command, and we say the user, meaning me, has execute permission on that thing. Okay. So so now we have a shell script. So the three ingredients to a shell script are: the first line needs to have bin bash on it, it needs to have executable permission, and it needs to be in your path. Okay? And at this point we stop with this file and we go to, it's not open yet, where is my, oops, no, not Acrobat, go away. Open with preview. Okay, we switch to the shell scripting presentation. This stuff is so I said that the shell is that thing that listens to your commands and it executes them. But so that's bullet point number one. Bullet point number two is you can chain together commands with pipes. So that's what you did with grep and then piping that into WC or TR or something. So you can take commands and cobble them together. But the shell is also a programming language, and so that's what we use it when we write shell scripts. So So what are the typical ingredients of a programming language? There are variables, there are control structures, there are data structures, and you can write programs. And if you've ever written in Python or BASIC, then you know that sometimes you have an interpreter and you can type commands interactively. Okay, the shell has variables, it has control structures, you can write programs. The only thing it kind of is missing is data structures. So, just with the variables and control structures, you can write interesting enough programs. So let's see what we can do with shell programming. So in the shell you have variables. So you say variable equals something, and then so setting a variable, you just use the name of the variable. If you use a variable, you start it with $. So title equals that, and echo $title. Okay, please try all of these things for yourself. The syntax is finicky. There should be no spaces around the equal sign. So type a bunch of these commands, see the various error messages. So when you're typing this, you're really typing statements in a programming language. But because it's an interpreted language, you can actually talk interactively to it. You don't have to put it in a file and compile it. You're talking directly to the shell language. So the first two spit out all sorts of error messages at you. The third one is correct. The third one is correct. You're setting a variable, and then the fourth line, echo A. What does that do? It echoes the string A, yes. So if you want to use a variable, you need to start it with $. So did everyone type the fifth line and it answered back the title? Yeah, without the quotes, right? So you need the quotes to define it as a string, but then after that, the quotes disappear. So it's a string variable, yes. Yeah, okay, so the shell is one of these languages where you don't have to say what type a variable is. And so if you make the string 1, 2, 3, then you can easily let that be interpreted as a number. So you have to police yourself. There is no explicit declaration as integer, so it is called weak typing. Strong typing is for people with weak memories. Okay, so variables start with a letter. The variable name cannot have a space in it, but the value can, of course, have a space in it. Not punctuation marks, and there is a bunch of reserved words. Okay, so there are certain variables that are always defined for you. $home and $path are two popular ones, and typically the ones that are in all caps come from the system, but not necessarily. So $home. See, I'm in some directory, and if I do cd, I get back home. But there is a variable $home, and $home is the directory that you go to when you do a cd. So you can also do cd $home, and that's where you are. But the $home variable, it's very useful to define your own variables. My project directory is over there. So this is this means that you don't have to remember. Sometimes you have a directory that goes 5, 6 deep or something. So you have a projects directory and then projects for this advisor, sub. So you get 6 deep or so, and you don't want to remember that. And so you just set a variable. Of course, setting that variable means that you have to know the value. So we'll show in a minute how you can save them somewhere. So when you set a variable, you often see the word export. Let's skip this. Let me put it this way: if you define a variable in a okay, you're going to get startup scripts on the next slide. If you define variables that have to have some sort of a degree of permanence, then you always put export in front of them. You can do all sorts of funky stuff with variables. See, there is the who am I command, and if you would type my name is who am I, and you want my name to be your login name, that of course doesn't work. So what would you do? Try to execute this variable. Nah, doesn't work. So you can do. So what you do instead, if you do this, and then you do echo. So this means that you've declared my name to be whatever comes from executing the whoami command. And there are all sorts of things you can do with variables. So this is a cute one. And like I just said to you, if you make a variable that looks like a number, then you can do so conversion from string to integer goes fluently. And then you can do, let's say, A is first, B is second, C is $A, $B. Does anyone want to guess what the $C is? Would that be AB or $A, $B? No. So you can easily concatenate variables together. They're strings, so just put them one after another. If A and B are directories, then you can get a new directory out of it. So you can do all sorts of funny stuff with variables. The first exercise is kind of an obscure one. Okay, let's everyone do this. Startup files are very useful, and it's almost a science to know that there are various startup files which get read in various forms. So a startup file gets read and executed every time you create a new terminal window, every time you create a new shell. And the best way to do things is to put stuff in a file called .bashrc, and then you also create a file .profile, which mostly contains this line. So everyone type. Create a file .bashrc with that line in it. Create a file .profile, which contains that line, and then create a new terminal window. So like I just said, my project dir. So shell variables are a convenient way of storing information that you have a hard time remembering, like where is my project? And to make sure that you don't actually have to type that every time, if you put that line in a startup file, then that startup file gets read every time you open a terminal window. And so this line gets executed, and so the variable gets defined every time you open a terminal window. So it's a good way of setting up your environment before you start working. Okay, so okay, cat into dot profile source $RC. I've done the absolute minimum. So I can open a new terminal window, or I can just start a new interpreter here. And now there should be a variable. Hey. Okay, so I've put the definition of a variable in .bash rc. My .profile says just read the bash rc. I started a new shell, and that shell then read the startup files. And so now you see that that this variable that I defined is defined there. So startup files are very useful. So one thing you can do with startup files, if you write shell scripts, you often want to have them in some central location. So it is common practice to create in your home directory a bin directory. And if you create shell scripts, you put them in that directory. Okay, so then shell scripts have to be on your path in order to be found. So so if they go in the bin directory, now you have to add that directory to your path. So let's see, echo sorry. Export path is $path $home bin. Okay, so this is so this is typically what a startup file looks like. You define a couple of variables. You also define aliases, which we didn't discuss, and you update your path to make sure that your shell scripts get found. Okay. Okay, let's do some actual shell programming. So a shell script is supposed to look like a program. So you want to type my shell script, my file, my other file. So you want your shell script to look like a command that takes arguments, right? Okay. So for that purpose, inside a shell script, there are a couple of predefined variables. Every variable, when you use it, starts with a $. So for instance, $hash means how many arguments are there for your shell script? Okay, everyone, please try to finish this. So I want a script where this is what I want. So as a first step to shell scripting, I want a script that just counts how many arguments there are. Okay, the beginnings of it are up there. So you create a file, you make it executable. And let's say you run it locally. So in order to do this, you need to look at the previous page, right? Jason, reminder, before you close down the chat, can you save all the text to a file? Okay, what goes in the dot dot dot? That's the easy part. What do you put there? Okay, you want your shell script to say there are so many arguments. How many arguments? $hash, right? So bin bash echo there. Oops. There are permission denied. What do I need to do about this? We did that somewhere. Where can't I scroll? Okay, so you need to make this executable. Hey. Okay. Now I hope that everyone has mastery of some editor. No, actually, so the next thing we're going to do is flow control. So the shell programming language has the usual conditionals and loops. So we're going to use the conditional statement. If something, then something, or if something, then else, or if, then else, if, etc. So the shell programming language is pretty finicky. So conditionals are usually written with square brackets. But you have to be very careful that here and here you have to have a space. And probably also spaces around the operator. So it's a bit finicky. You get very bizarre error messages if you forget about that. It's not the greatest programming language, but it's very quick and it's everywhere. Okay, so how do you do a conditional? So suppose you have a variable a, and you know that there is a number in it, so you can test if a greater than 2. So there are numerical tests, and there are various tests that are more related to kernel, to Unix operations. So you can, for instance, ask if there is a file.profile, and if you want to know precisely what sort of tests are available, then you can do man test. That will tell you all that stuff. Okay, so let's take your script, copy it to a new. Oops. Copy count them to name them. So what I want now is a script that says there are so many arguments, and if the number of arguments is greater than 0, then it should say the first argument is. Okay, and what are the tools that you need for that? Okay, so there is the test. So note, if test semicolon, very important, then, very important, no semicolon after the then. It's really finicky syntax, but so if something, then echo phi, and so the test should be the number of arguments is more than 0. Okay, so here you have the greater than test, and the number of arguments is $hash, and the first argument is $1. Okay, there you have all the tools. Go put them together and write a shell script. I hope that everyone speaks Emacs or VI or Nano, Pico. Any other editors? Right, but I don't know which ones are available. See, I think Emacs is. Hey, there is an Emacs. Okay, me happy. Yeah, so for this exercise, you need to know some Unix editor. Feel free. I will think less of you for doing it, but start typing, and then these control codes. Type file. Okay, how's everyone doing? So many arguments. If number of arguments greater than 0, what? Then oh boy, oh boy, oh boy. Ah. Okay, did everyone solve the riddle? So you need to have the test if the number of arguments is greater than 0. Make sure you put spaces around everything. Don't forget the semicolon. And then you need to say the first argument is $1. Okay, so very simple shell script. Yeah. Okay. So that was using $1. That was using a numeric test with greater than. There's also equal so we're getting to the end of this session, so I'm not going to go into, I'm not going to make you do more exercises. I hope that this shell script was an illustration. So let's see. So I had that shell script. And I was calling it with the /, note the /. Let's move this script to my script directory. So now if I want to use the script, I can of course use the explicit path. This works because of the explicit path, but it's a it would be so much nicer if the command behaved like a system command. And that doesn't work because okay, why doesn't that work? What are the 3 requirements for a shell script? First line needs to say bin bash, #bang bin bash. It needs to be executable, and condition number 3, the system needs to be able to find it through the $path. See, $path is all sorts of system stuff. So oh, in fact, it was there. So I just need to make sure that so I could just call a new bash. So I can just open a new terminal window or start a new bash, but you can also source do this. Now if I echo $path, okay, so now you see that $path is everything that was in that the system provided me, and it has added my bin directory. So now the script should be findable. Okay, what did I do here? I typed $nam. This is another shell shortcut. Typing $something means find the last command that started with this. So So if I do name So if I have a command, we're going to name them under Torah, it executes that, and then dollar now means find the last command that started with that, and it re-executes it. Okay, that's probably about enough material. The shell programming language has several control structures. You've seen the conditional. Looping is also an important one. And your normal programming languages basically have only one type of loop, namely loop a numeric index from here to there. The shell looping construct works differently. It says loop with variable in a set of values. So this kind of makes sense because the shell is about files, and so you typically want to iterate for every file in this directory, and not so much for I is 1 to 100. So the for loop is actually cycling through a set of values. Okay, I'll probably leave you with so the fun part of the shell, and this is much more for the bash shell than for the C shell, is you can put all this stuff together. So I've written a one-liner here. So for f in star, okay, star means everything. So in fact, it means all the files in the current directory. So with f is any file, and then if you do a for loop, it defines a variable so you can inspect it. So if f is name, then etc. etc. So I'm not going to explain this in detail. Just as an illustration, you can put all these things together and do various bookkeeping tasks, control structures. There's a while, there's a case. Here scripts are very useful. But we're running out of time, and you guys are probably getting tired. So I'll stop here. The slides that I didn't cover, please read through them because there is a bunch of material in it that will definitely be useful to you at some point. I wish I had time for the here script, which is a way for a shell script to write another shell script. This is terribly useful. I do this all the time on a Stampede. Most of my job submission scripts get written automatically by shell scripts. So this is cool stuff, and I'm running out of time. Okay. Yeah. Okay. Let's say I stick around. We stick around for half an hour or so. If people want to do more exercises, I'll be here to guide you. But you've been trying to keep up with me for the last hour and a half, so I'll give your brain cells some rest. My name is Victor. If you have questions about this, you can email me. You can also, if you have questions about just using Unix attack, you can submit a ticket through the ticket system. There is a lot of information on our website. My slides are all on the training website, so I hope you've found them and downloaded them. we didn't get to all the exercises, please do them at home, because every exercise does illustrate some point or other. If you have questions about them, just mail me. And thanks for coming, and I hope this is useful. Is anyone interested in getting a tour of the machine room? No? Yes? Raise a hand. Say yes. Shut up. Okay. Some other time. Okay, we're closing the session, but actually we can keep the chat open. So I'll stick around for half an hour if people have